We have two examples here. Set up the integral, which finds the volume of the indicated solid. So number one, it's the region bounded by these 4 bits, the parabola y equals x squared, x equals 0, x equals 2, and the x-axis. And we're going to revolve that about the x-axis. Second problem we're going to work is region bounded by y equals x squared, y equals 0, y equals 4, and the y-axis. But here we're going to revolve about the y-axis. All right? So let's see here. I'm going to draw and probably fail to draw very well. I'm going to draw a rough picture here. This is 2. This is the parabola. This is 0. So this is the region bounded by the parabola, x equals 0, x equals 2, and the x-axis. So it's this region, and we're going to revolve that about the x-axis. And so it's going to generate, it's kind of like that, what is that movie, Inception? It's like the little top that Leonardo DiCaprio had in the movie Inception. That's the region we're looking for. And so if we choose any point, we need to know what is that radius. Well, that radius is just the function value. And so the volume is straightforward. The volume is pi. Integral from the limits of integration are the endpoints of the original interval, which is 0 to 2. And then we have the radius, which in this case is the function value, dx. And all we're asked to do is set up the integral. Make sure to answer what you've been asked. Don't answer more than what you've been asked. I know I sound like a lawyer, but don't answer more than you've been asked. All right? So, next piece. Well, let's check out the region here. This is, again, the same parabola, but now, let me get a better picture here. We're bounded by y equals 0, which is this point, 0. Y equals 4, which is this. And now we're revolving about the y-axis. Here we revolve this about the x. Now we're revolving about the y-axis. And if we do that, we don't generate this little top that Leonardo DiCaprio had in the movie. Now we generate, it's almost like this is actually a bullet shape. Bullets actually are parabolic shapes. So it's this paraboloid we have here. All right. Now the radius, if I choose a point, now notice, the axis of revolution, in this case, the axis of revolution is the y-axis. Here the axis of revolution was the x-axis. And so when we're using this procedure is called the disk method, D-I-K or C, you can spell disk however you want to spell it. The disk method, because the representative piece we have here is one of these disks. Here the representative piece was also a disk. It's just here it's oriented revolving about the x-axis. Here it's oriented revolving about the y-axis. The disk we have, if we take it away from the picture, that's this disk. This is called the disk method. If we take this out of the picture, it would look like that. So here we have a disk with a vertical axis. Here we have a disk with a horizontal axis, but this is the disk method. And when we're working with the disk method, the axis of revolution is the axis of partition, which means the axis of revolution is the variable of the integral. If you're revolving about the x-axis, the integral is with respect to x. Here we are revolving about the y-axis, so whatever else happens, we know this, whatever else happens, this integral is going to be dy. The axis of revolution determines the variable of the integral. The axis of revolution determines the variable of the integral. The axis of revolution determines the variable of the integral. If you're revolving about the y-axis and you're using dx, using this method, there's a really good chance things are not going to be correct. So we need pi. Now the interval of partition is on the y-axis going from 0 to 4. But I need the radius squared. Watch, what I'm going to put here in the green, that is not correct. Well, the squared's correct. But this is not correct. This is not correct because this is a y integral. This variable needs to be y. If this is a y integral, then you need to take this function and you must solve for the other variable. If we have y equals x squared, that implies the square root of y is the function. The square root of y is the function. And so we may write this as square root of y. That's now the function squared. That's the piece we're looking for. All right, so if we're revolving about the y-axis, this is dy. It needs to be a function of y. If you have a function of x, then you need to change that into a function of y in order to make this integral match up.